Okay, so let's be real. We are surrounded by data, right? Charts, graphs, spreadsheets, they're everywhere. But how do you actually cut through all that noise and figure out what it all means? Well, today we're going to break down how to draw rock-solid conclusions from pretty much any data you see. And look, this isn't just about acing some test. It's about seeing the world with a whole lot more clarity. But before we dive into the right way to do things, we got to talk about the trap. Yeah, there's a trap. It's a mistake that almost every single one of us makes when we first look at a chart. Does this look familiar? You're just staring at a chart and your brain kind of fogs up. You're not alone, I promise. It's that feeling of being completely lost in the numbers, and it's totally normal. And here's why that happens. There's this little battle going on in our brains. It's our gut feeling versus the hard evidence. On one side, you've got all your assumptions, your guesses, everything you think you know. And on the other, just the cold, hard facts right there on the page. You know, mastering data is really all about knowing which voice to listen to.
So how do we make sure we're sticking to the hard evidence? Well, it all comes down to one really simple but powerful mindset shift. Let's just call it the golden rule of data.
To really get this rule, first we need to understand what most of these data questions, whether it's on a test or in a work meeting, what they are not actually asking you. See, they're almost never asking for your opinion. It's not about what do you think. Your beliefs, stuff you learned in a class last year, your gut feeling. In this context, honestly, none of it matters. Instead, these questions are really designed to test one very specific skill. They're only asking you to do one simple thing. And that's it. What can you prove? That is the entire game. Just asking this one question completely shifts your perspective from guessing to demonstrating. It's not about what you know. It's about what you can show, using only the data that's right in front of you. And here's that rule in action. It's so simple. If you can't physically point your finger to the evidence on the chart that backs up what you're saying, then it is not a valid conclusion. It's as simple and as strict as that, period. Okay, so we've got our golden rule. What can you prove? Awesome. But to prove anything, you first have to understand the playing field, right? And that means we need to decode the experiment that gave us the data in the first place. Any experiment, no matter how complicated it seems, it really just boils down to these three questions. First, what changed? This is the thing the scientists were intentionally messing with. Second, what was measured? This is the outcome they were watching to see what happened. And third, what stayed the same? You gotta have constants to make sure it's a fair test. If you can answer these three, you've basically cracked the code of the experiment. Great. So, we've got the rule, and we know how to decode the setup. Now for the main event. How do we actually build one of these rock-solid conclusions from the ground up? Let's start with a really clear definition. A proper conclusion, it isn't just a summary, and it's definitely not a wild guess. It's a very specific kind of statement. It has to be based only on the data you see, it has to be supported by evidence you can literally point to, and it's got to logically follow the trend that the data shows. So let's just lock this in. Think of it as a three-point checklist. Is my statement based only on the data? Can I support it with specific evidence from the chart? And does it logically connect to the trend? If you can say yes to all three, boom, you've got yourself a rock-solid conclusion. And we can make this even simpler. Let's boil it down to a clean two-step process. Step one, just look at the data and identify the basic trend. As one thing goes up, what's the other thing do? Does it go up, down, stay the same? Then, and this is the magic part, you just turn that observation into a simple sentence. For example, let's say you've got a graph. The bottom axis is temperature, the side axis is reaction rate, and the line goes up and to the right. Your sentence is literally as simple as this. As temperature increases, reaction rate increases. That's it. That is your conclusion. Notice you're not explaining why it happens. You are just stating what the data shows. That's the key. Once this method really clicks, it stops feeling like some strategy for taking a test, and it actually starts to feel like a new superpower for just thinking critically. Seriously? If you take only one thing away from all of this, let it be this right here. It's the absolute hardest rule to follow because we're all trained to bring our own knowledge to every problem. But in pure data interpretation, you have to fight that urge. What you already know doesn't matter. Only the data matters. Let's say it together. No outside knowledge
And so we end up right back where we started, but now with a completely new perspective. The next time you're faced with a chart or a graph or a big table of data, don't ask yourself, what do I think? Instead, ask yourself the only question that truly matters. Now, what can you prove?